Hello everyone, welcome in Finance Element Method class. Today I'm going to show you how we can calculate or find thickness of the shape. So here in this example we have a 2D triangle, and in this question already given the values of strengths and stress because and also give a point is plate stress here, and also the dimensions. So first of all we should find the area of the shape. So by using this rule, depend on x and y and z for each point. As you see here, for the node number 1, we use x2 y3 minus x3 y2. This is for node number 1, and the y2 minus y3 all by xy for node number 2, and also here for the node number 3. After that, just substitute your values and you can get the value of area for this shape. After that, you should find criteria for shape functions. Actually, in the beginning you should find the equations of n. So here actually you can depend on the values of x and y for each point or node. So in the node number 1 we have a1, b1 and c1. I hope you can see. So this is the rule that you follow, how you can find a1. This is this way I can find the value of a from this one, and for b1 also I can follow this one and the c1. You can go to some references if you want. How can these values or these rules come from what? Just substitute the value of x and y depend on the number of nodes. Okay, like here for example c1 x3 minus x2, that means the x in the node number 3 and x in the node number 2. Same the way here for the a2 b2 c2, and also same here for the a3 b3 and c3. This way I just to give you the key for this rule about the circle. If you watch my previous videos, I explain for that I, J, K, L. It's just about the circle. If you want to work on I, delete it and start with J, K, L. If you want to work on J, okay, delete J and take the number 1 K, number 2 L, number 3 I, and so on. So now continue, and after that find the n. N is the node for each node. This is node number 1, node number 2, and node number 3. And this the rule that you can follow it to find the equation, or I can say it's like a equation for node number 1 and node number 2 and number 3. Depend on the general rule here. So here this is for node number 1, node number 2, and node number 3. After that, go to for checking the first of all, shape function is equal to 1 for all nodes. So take node number 1, node the 1 by 1, and also this condition you should get the value is 1. And also for the just take the node, like here for example for node number 1, take this one node and substitute the values of x and y of node number 1. So node number 1 here we have 0 and 0 because it's laid on original point, 0 by 0. So just substitute and you will get 1. So that's correct. And same for node number 2. Do that and substitute. We have for node number 2 we have only x and y. So also just take node by node. We work on node number 1. So take the values of node number 1, x and y, and substitute in others nodes. Same that when you take the node number 2, I mean the excel of number 2, okay, we have 2 and 6. Just substitute these values in the equation of node number 1 and equation node of number 2 and equation of node number 3, and so on for the node number 3. After that, shape function is 0 for other nodes, and that's okay. I think I didn't solve this one, sorry, but just you can go to previous videos. Okay, I already solved one by one and explain more about this, but just quickly. So node and node number 3, sorry, actually point number 3. Point number 3 is summation of shape function is 0. So already I done of summation, we got 0. And the last point is summation of derivation of shape function is 0. You can derive on x and on y, so I got also 0. After that, work on B matrix. Actually B matrix, you can find it from x and y for each point here in this example, okay, and substitute your values. Actually yes, substitute your values, and you can go to a previous video, or actually let me to just it's actually the B matrix is come from derivation, like for example for just for refresh, but you can go to previous videos. For node number 1, dn1 and 0 dn1 over dy, sorry, here dx, okay, and d1 over dn1 over dy, and dn1, I mean the derivation of node number 1 on x direction. This is for node number 2, and so on for the others nodes. After that, you can find these values and make it transform because I want in the K matrix I want matrix P by transform form. Assume if doesn't given the elasticity and also Poisson ratio, you can assume it, or you can, or it's given, that's okay. After that, find the D, because here it's as mentioned of plate stress, so I used stress for D matrix, and just substitute here. The V is the Poisson ratio. Poisson ratio here, the V Poisson ratio. Just maybe it's not clear for you because the writing is small. Then go to next slide. Next slide, just time D B transfer and D matrix. After that, you can see or you can apply or doing the K matrix. Here is equal. This is the rule of K matrix. Okay, just substitute your values for P transfer and not P transfer, B matrix transfer time D. This one is already here, I got it. Time B you can go to previous slide. This is for B, just substitute here, and for the A already calculated, and for the T we don't have the value of T. After that, you can follow the rule of F, the force, F equal K time displacement. So K is here. After you calculate all these matrix, you will get this one. Also, and for the force, you can divide it each point for two forces. I mean, on force on X direction and on Y direction. Here we have only on node number 3. Yes, on node number 3 I have 200 kN. It's on Y direction. So for the node, this is K1 on the X, Q1 or F1, up to you. Q1 is mean the force for the node number 1 on X direction, and here for the Q2 is mean the force on node number 1 on Y direction, and Q3 for the X direction on the node number 2, and Q4 for the node number 2 on Y direction. And for the node 3, actually we have only one force on Y direction, so that assume or just put 0 on X direction, cannot write Q5 for example. So here is 0, and here our force that already given in the figure is 200. After that, just you can solve it by calculator or by traditional method by using equations to get the value. After that, actually we find the from equation number 1 and equation number 2. This is equation number 1, equation number 2. Actually I find V3 and U3, the the displacement. Okay, and after that just substitute the values of the rule of Cetras. This is the rule of Cetras. The values of D matrix and B matrix time displacement. Just substitute and already you will get the T, especially because the T from I think you it yeah, because yes, because if you substitute the K matrix there, it already K matrix by T. Is I make it larger, here the K matrix you have this T, okay, unknown, so still T, small t, the thickness, and from the K matrix you can get the T, okay, and T here is 0.117 meter. So this is actually the way I can find the T, and also the stress is already given in the example if you looking in the first slide. So until here, thank you so much for kindly watching and listening.